Okay, as we continue with video 6A, we're going to be moving into finding and naming parts of a circle. So I just want to remind you guys to please draw all these diagrams in your notes, because just walking through the steps of actually drawing these circles and all the different radii and diameters and all the different vocabulary words that we defined in the last video is really going to help cement the idea in your brains so that it'll stay there long term, okay? So the first thing we're going to do is we're going to draw this diagram, which is from example 1 in your textbooks. So we're going to start with a nice big circle, and then I always draw the center as my next step, and we've labeled that as center K in this diagram. Then I always draw any diameters, because that tells me kind of where the rest of the pieces should get put, and this is R on the left hand side, P over here. Then I'm going to draw in any other radii or chords that might need to be drawn. So here we go, and there's a chord there, and then we've got another one coming down here. So all you have to do, you guys, is just remember your notation on this type of problem. So I'll just remind you of that. Make sure you're keeping in mind notation. And then just identify is really all we need to do in this diagram at this point. This is point N and O up here and Q down in the corner. And so now we're just going to go ahead and use our notation and find the different parts of the circle. So part A of this example, part A of example 1 asks us to name the circle. So just very carefully remember we've got a circle there with a dot in the middle, and we want to name it by the center point, which is just going to be circle K. To name a radius of the circle, we actually have several to choose from. I'm going to use this one right here, so we're going to call that KP, and remember we want to have our segment notation across the top. But just a reminder here, this actually could be K and then anything that you wanted to in that second letter, as long as you're going out from the center to a point on the circle somewhere. That's a radius. A chord of the circle is a chord, is a line segment that joins 2 points on the circle. So it looks like we already have one of those right here drawn in, although technically if you wanted to join any 2 points and name them with a segment line over the top, that counts as a chord as well. But I'm going to go with the one that the book is showing us here in the diagram. So that's going to be chord NO. And then a diameter, we really only have one in this diagram, because I hope you can see here this is not meant to go in a straight line from O to K to Q. So we do have a diameter going across there from R to P, and so that is our diameter, RP. And again, make sure there's a segment line. That's all we have to do, you guys. So let's go on to the next problem here with example 1B. And anytime there's a B next to the examples, just like in our trig unit, you're going to not be able to find the diagram in your book, because it's another one that I'm giving you. So here we go. This diagram has a center for E. We've got a diameter going across here vertically from the top, which is B, to the bottom, which is D, and a diameter coming across at A and C. And then we're going to join these 2 points right here and these 2 points right here, so that we have this diagram to name our circle. We know it's circle E. The radius of the circle, we've again got several to choose from. I'm going to use EC, but remember it could be really anything that's E and then some other letter to go next, so long as it goes out from point E. A chord of the circle, we do have 2 to choose from here. We've got both from A to D, that chord, and just this tiny little chord up here from A to B. I'm actually going to write them both here so you can remember that there's a couple of choices. So AD or AB, again, segment notation. And then a diameter, again, we have a couple to choose from. We could go with BD, going across there vertically across the circle, or we could also go with a C, which kind of goes across at a diagonal. But both of those go through that center point E, and that's really the only thing you need for a diameter to do. Okay, so those are the first two examples of the same kind, which is really just naming and finding the names of pieces of a circle. Next, we're going to actually take our diagram and we're going to put some measurements to it, and we're going to see with the relationships that we know with diameter and radius how we are going to find missing pieces. So as you can see in this diagram, you guys, or in this problem, the same information that's used here in example 2 in your textbook, they're actually giving you the same diagram and then a bunch of different scenarios of beginning measurements. So I think it really makes sense for you guys to redraw and resketch and relabel the diagram each time, as I've said for you to do here. So I'm going to do that really quickly and just draw the diagram 3 times over. We've got one here, we've got one here, and we've got one here. And we've got diameters DF and PG each time, and they kind of make a little X there. And then we have another chord that comes out from the center, which is A each time. And it kind of comes out at an angle over to the left. So now that I have the diagram as far as the pieces of it go, I'm going to be interested in putting the labels on where I see the information given to me. So if I have DF equal to 10, then I need to make sure I know where D and F are, and so we've got D. So continuing with examples just like the one before, again this one is not in your book, but we want to start by sketching a new circle for each letter part to this example, just like example 2. This time we have a few other pieces to the picture here, but we still have this vertical diagonal in each one, so let's sketch that one first. Then we have another diameter coming across. And then in each tiny little corner here we've got a chord coming up, and then another one coming down, or a radius, sorry, those are radii coming out there. And if we wanted to go ahead and label the points that we need, on this first one we need to know S and T and then R. On the second one we need Q, and of course the center is R again, and then M at the bottom, and then center at R on part C, and P is that corner of that radius there, and N is this corner. So ST on this first one is our diameter, and we want to find, I hope you can see, if we want to find RS, that is a radius. So all we're going to do is we're just going to cut that in half using that formula that we said before. Diameter equals twice the radius. If I know the diameter, I'm cutting the diameter in half to get the radius, so that gives me 9. For RM on the second example, RM is a radius to begin with, and QM is a diameter. Use the formula, plug in what you know. QM has to be double the radius, or 48. And then again on this last one you can see they're giving me RN and I need to find RP. Well, all radii are going to be congruent there. So if I know one, I know every other one, and that's going to be 2. Okay, the last little bit of this video is going to take the ideas of radius and diameter and going to start actually overlapping them in a diagram. So this diagram is a little bit more complicated to draw, so bear with me here. Let's read the example. It says the diameters of circle A, circle B, and circle C are 10 inches, 20 inches, and 14 inches respectively. Now just remember what that word respectively means, you guys. That just means that in the same order as it was stated, that's where the diameters are going to land. So if we go ahead and we draw, I always start with the big circle in the diagram that you can see there. So we've got, that's going to be circle B in the middle, and we're going to draw across that diameter. Circle A, as you can see, is right at the center of circle A is right on the edge of circle B, and circle A is smaller, so we'll make that circle A. Then this point right here on the edge of circle A is point X. And then we've got another circle with its center at the end of the diameter of circle B, which is a little bit bigger than circle A, and that's circle C. And then the point that intersects in the middle there is Y. And then we've got C over here. Now I know this diagram is in your book, and you may be able to reason through it, but it's really helpful, I think, for you to go through and resketch it so you can see all of the overlapping pieces. And so now what we're going to look at is finding what we need to find, which is over here. We need to find XB and find BY. Using this information, remember all of this information up here. So what I'm going to do is going to go through this kind of circle by circle. And so if I have circle A, and I know its diameter is 10, then that means its radius is 5. So onto the diagram I go down here, and I know this little bit right here is 5. And so that means the other side there, XB, is also 5. So there's my answer for the first one. Now, the second part is a little trickier because that's BY, which is really a portion of radius BC, but we don't really know, even though it looks like it's right in the middle, we don't really know that that's exactly halfway. So what we do need to know and take care of is some measurements about circle C at this point. So if we go to our information about circle C has a diameter of 14 if we think about respectively. C is the last, so we want to go with the last measurement in the list, which is 14 for the diameter. And so that means the radius is 7. So really quickly, if we go through here and we take the radius of 7, so that's YC, and we know that our radius of our circle B has to be given already as 20, or excuse me, the diameter is 20. You can see that I've got just one little missing piece there. So if I've got 5 and 5 and 7, hopefully you can see that the missing piece BY has to be just 3. So kind of process of elimination there, you guys. That's what we're working with, okay? So let's keep going. We'll do one last example in this video, and then we'll go on to the next video and talk a little bit more about circumference. So again, same type of problem in this one where we're going to be overlapping our diagram. In this case, we kind of go from big to medium to small circles. So let's start with our big circle here, and then its center, and then the next circle has a little bit of overlap there, medium size. Its center, notice though, is not on the circle. That's its center right there, center Y. This is X. This is Y. And again, we want to make sure we're drawing the diameter all the way across here. And then circle Z has its corner right there. And so we've got it centered on Z. And then we've got some pieces in the middle where we've got F right there, and we've got G if we were to extend all the way to the end of circle Z. And so we want to find E starting over on the left all the way to Z is our first measurement that we're going to find. So we've got some measurements to put on here. Let's go up to the top. If the diameter of circle X is 22, thinking about the first one in the list, then that makes the radius equal to 11. So look at our diagram, guys. That means EX is 11. That also means that from X all the way to the edge of that big circle is 11. Now y is somewhere in the middle there, so let's talk about how much of that is going to work for y. If we look at circle's diameter is 16, so that means its radius is 8. And if we go ahead and put 8 onto our diagram here, on this side is 8. And then our last one, our last measurement, is that circle Z has a diameter of 10, which means its radius is 5. Then we can go ahead and figure out on the diagram, this is 5 up here, and so is that 5. So remember, if the diameter of circle Y here is 16, we have already found the radius is 8, then that means from Y to Z has to be a total of 8. And if each side there on circle Z, each radius is 5 here and here, but yet this whole thing from that point into Y and from Z into Y is supposed to be 8, then I hope you can see what piece is missing. That's going to be 3. So now we're going to find the missing pieces there, now, or find the exact measurements that we actually need, going back over here. So if we're going to find EZ, then E to Z is 11 plus 8 plus 3 plus another 5. So that's going to be 27. And we were given units here, so this is going to be millimeters. And then finally, to find XF, we're going to add up the pieces in between there, and XF is just got to be 11. There you have it. Make sure that you please are going to the end of your whisk here, find the yellow page in your packet, and make sure that all those whisk problems that are like these problems in this video from examples 1, 2, and 3 get done in your packet for tomorrow. I'll see you guys later.